composite functions are using function notation, but we have two different functions. We have a function called f of x equals 2x plus 1, and we have a function called g of x equals x squared minus 5. And I could easily plug an input value into either one of these equations, but what I want to do is I want to plug an input value into one of the equations and then take that and plug it into the other equation. Our first example, g of f of negative 1, when it's written like this with using a lot of parentheses, we work our way inside and out. So first I'm going to do f of negative 1. And so f of negative 1 would be 2 times negative 1 plus 1 is negative 2 plus 1 is still negative 1. And so since I want g of f of negative 1 and f of negative 1 equals negative 1, I'm really doing g of negative 1. And that is negative 1 squared minus 5, which is 1 minus 5 is negative 4. So g of negative 1 equals negative 4, but g of f of negative 1 equals negative 4. So another way of writing these problems is using f of g of 3. This little bubble here kind of stands for the word of, f of g of 3. And what you do is you first do the function to the right, and then when you get that answer, you do the function to the left. So first we're going to do g of 3, and g of 3 is x, but 3 squared minus 5, that's 9 minus 5, and g of 3 equals, hold on, messed up a little bit here. This is minus 5, so that's 9 minus 5 is 4. G of 3 is 4. And so we want now to do f of 4. And that's 2 times 4 plus 1 is 8 plus 1. F of 4 equals 9. So that means that f of g of 3, our original, gave us final answer of 9. Now, what can be tricky sometimes is not when you're plugging in a number, when you're plugging in a variable like x. Like first I'm going to plug x into f. Now, if I do that, I just get f of x, and I know that is 2x plus 1. F of x is 2x plus 1, so if I plug in an x for x, I still have 2x plus 1. And so now I want to work it in g, where I'm plugging in the function of f. And so that is 2x plus 1 squared minus 5, because for g, whatever you're plugging in, you have to square minus 5. And so 2x plus 1 squared, a binomial squared, I need to think 2x plus 1 times 2x plus 1. And I got to work the FOIL out, the distribution. I can end up with 4x squared. Let's see, I'll get a 2x, another 2x for a total of 4x, and then a plus 1. And then add that minus 5 on the end. We get 4x squared plus 4x minus 4.